we are with this code, and this is our topic, MQTT security implementation and analysis. So first is about the project overview, and our topic is MQTT. Basically, MQTT is a message transport protocol in IoT, and it's very good in IoT devices because it's kind of lightweight. And in IoT environments, the IoT devices are kind of resource limited. So in that case, there might be some security issues. And we are going to study MQTT and OOs. The problem is that the credentials transmitted in MQTT are in plain text, and some issue might happen that malicious client can eavesdrop some network packets and even steal the user data. And OOs will authorize the IoT devices in a more secure way. And then we are going to study MQTT and payload encryption. The problem is that there's kind of lack well-defined encryption method for MQTT payloads. And TLS might be a good option, but it's kind of bringing lots of overhead. And we are going to research and analyze other solutions and their use cases. And this is our current progress. We have researched on original Mosquito security mechanism, including the client authentication and data security. And we also studied open source implementation of MQTT and try to look for the way how to develop a customized plugin. And we also designed the OOS workflow to try to fit into the MQTT scenario. And this is our hardware demo. So basically, we have already set up an environment consists of 2 Raspberry Pi boards. And one is used for MQTT broker, and the second one is to try to simulate an IoT device. And the picture on the right is the test of connection. So basically, we can try to send a packet from one device to another device. And this is our current research progress and the blockers. So the first problem is that the previous environment setup, which involves a home assistant, kind of very abstract. And because there's like ZigBee and ZigBee to MQTT, so there's many encapsulations, which is not very good for our study. So we are going to simulate an IoT device through the Raspberry Pi board. And the second problem is that there's no existing out-of-box plugins which integrate OOs into Mosquito. So we only found some repos which are either archived or there are only some naive implementation. And our solution is to try to develop one on our own. And we are going to focus on the plugin development. And in the future, if that works, we can try to integrate that with the Home Assistant. And the last problem is that Mosquito provides a kind of auth plugin interface to customize the authentication protocol. But there's no interfaces to customize the authorization protocols. So our solution is try to study the source code of Mosquito and try to develop a plugin for general purpose.
Now, before we start talking about our flow designs, I would like to make some clarifications first. We received some feedbacks from last time that some people think that we didn't quite get it clear about authentication and authorization. Here we want to emphasize that in our scenario where we have IoT sensors publishing MQTT messages to a MQTT broker, and IoT devices who subscribes to those topics in the broker and receive those messages. What our ultimate goal there is always that we don't want any anonymous publishing and subscribing happen. So we would always want IoT sensors, IoT publishers, MQTT publishers and subscribers to be authenticated. So from the IoT devices view, it's them that's authenticating themselves to the MQTT broker. But from the user, who is the owner of the whole system, from the user's view, it's him that's authorizing all his IoT devices to access the MQTT broker. Let's take a look at Mosquito's original client authentication first. Mosquito is one of the biggest open source MQTT broker out there, and it has 3 ways of client authentication. The first one is client ID, so basically each IoT device would have a client ID, and the MQTT broker would recognize them by a client ID. It's purely plain text, nothing else. And the second one is username and password, and this is the most effective one in the Mosquito setup, so that each Mosquito publisher and Mosquito subscriber will just possess a pair of username and password, and whenever they want to publish or subscribe, they just use those username and passwords to accomplish that. But the setback in this username and password setting is that, first of all these plain text, all these username and passwords are transmitted in plain text throughout the network. And secondly, if we want to, so basically we are, the user is creating and managing these username and passwords themselves. So that is to say, if you want to control every IoT device in your system in a fine granularity, you basically have to create a pair of username and password for each of your devices. If you don't want to do that, you can always create a single pair of username and password and let all your IoT devices use the same pair of username and password, but that's going to be very hard to manage and control the accesses of these IoT devices. And the third way of client authentication in Mosquito is client certificates, but this is the hardest to implement and to manage way, and it also requires more powerful IoT devices. So here's just a screenshot of we actually captured some network packets there, and you can see if the Mosquito clients are using username and password authentication. You can literally see the password field in the network packets. So it's purely plain text. That being said, that's why we would like to introduce OAuth, so that instead of letting IoT devices authenticate themselves using username and passwords to the MQTT broker, we want a way that the user can authorize all his IoT devices to get access to the MQTT broker. And OAuth is just such a protocol that we can leverage to make that happen. Basically, in OAuth, there are 4 workflows of how the whole authorization works. But since we normally IoT devices won't have any user interaction interfaces, so we were left with the only client credential workflow, which basically means that we have to put our credentials, the user's credentials, in every IoT devices of our own, so that when the IoT devices wants to access the MQTT broker, it will first talk to the authorization server out there using that credential of ours, then get back the access token, which is unique for every IoT devices. And after that, the IoT device would connect to the MQTT broker with that access token, and while the MQTT broker can check with the authorization server if that token is valid. If that token is valid, the MQTT token will just accept this connection and let the IoT device go through. That's the basic workflow of this client credential workflow. The good point of this flow is that now we don't have to manage username and passwords ourselves. The access token can identify IoT devices, and we just have to remember our own credentials on the authorization server, and which already exists. So basically, we don't have to create any new username and passwords. However, the drawback is obvious, right? You have to store credentials in your IoT devices, and that's very unsecure. And this is where we introduce our optimized flow.
This is our optimized flow. We still assume that we have very limited user interfaces on the IoT device, but we also at the same time assume that we can have some very simple settings on the hardware, which means we can set some IDs on the IoT device, and I will introduce the flow here. First, we still ask the user for the permissions to get the resources on the broker, and first we will ask the user to get a request for the authorization server and get the device ID and device secret. And the user can manually set the ID and the secret on the IoT device, and then the device can use the ID and the secret to ask for a temporary request token. And then use the token, the device can ask the authorization to get an access token. This access token is used later to ask for the broker resource. And when the authorization gets the temporary request token, it can automatically ask the user about the to authorize the device. This may by the means of the email or text message, and then user can click that I permit that this device can ask for the resources on the broker. Then the authorization once got this message, then can send the access token to the IoT device. With this access token, then the device can ask for the resources on the broker. So on this workflow, we don't need to put the ID or anything on the hardware IoT device in manufacture. This is very cheap, and we can use very limited user interfaces to reach the very secure thing.
So this week, we also did some research on the current data security mechanisms. Our focus on data security is on payload security and integrity. So for some reference, the default setting of Mosquito MQTT doesn't do anything with the payload security. It will just transmit plain text and did not check the integrity. However, the most popular way is to use the certificate-based SSL TLS support that exists in Mosquito. It's a transport layer solution. However, it needs to be run on powerful devices such as a broker. What about the limited IoT devices and the situations of short-living communications? That's the part where the application layer solution should come into life. That's where we have to do the authentication, payload encryption, and payload integrity separately. And for the payload part, the data security part, we are going to estimate about the the quality of the asymmetric and client certificate solution, and also symmetric encryption and the MAC solution. So the data security analysis plan, which is for our final update, our target will be targeting 4 simple communication patterns, that is long-living and short-living communications, and also for large payload and small payloads. We will evaluate them on the overhead of the message, memory usage, and their attack resistance. So for the goal revision of our overall project, firstly, we would like to base our development on Mosquito. That's because it's commonly used in community projects, and it can work as an add-on to Home Assist. Secondly, we would like to focus more on the analysis of MQTT security mechanisms, because there are trade-offs exist between the security and hardware limits, and the security features are needed under different use cases. And as the feedback suggests, creating our own encryption mechanism is not so feasible. So we were more interested in doing the analysis. Thirdly, we will take time to explore the benefits and limits of the OAuth workflows. That's what we did this week. Here is the timeline revision. And this is our reference. Thank you. That's the end of our presentation.